Okay, so 2.4 complex numbers, a plus bi. So how do we get an I? Does anybody remember?
It's
an impossible
imaginary.
number, like a negative number and a square root.
Right, it's the square root of a negative number. So you've learned before that you can't factor x squared plus 1. There's no solution, right? We've said there's no solution, but it's not no solution, there's no real solution. Because there is a solution, because if I took x squared equaled negative 1, I'd take the square root of both sides, right?
Mm-hmm.
And so I'd have x equals plus or minus, but the square root of negative 1 is what? I. This is nice because in previous years, this has been brand new information for the kids to get it. It's not brand new information for you, is it? It's just a review of what we did with it last year. We'll go a little bit further, but it's just a review. So it's not that there's no solution. There's no real solution. There is no x-intercept there, but there is a solution. So it's an imaginary number. What else do you need to write down on that? I don't know. You guys good? Okay. So powers of I. So the square root of negative 1 is I. And we can leave that my problem, can't we? Okay. What is I squared? Well, not 1. I squared would be
Negative 1.
the square root of negative 1 squared, correct? So it'd be negative 1. I'm just taking the previous term and doing it, right? So I cubed would be I squared times I, wouldn't it? Well, I squared was negative 1 times I would be negative I. And I to the fourth would be I squared, wouldn't it? Well, what is I squared? Negative 1. And we square negative 1 and we get 1. So there's a pattern. We have I, negative 1, negative I, and 1. You cannot leave any power greater than 1 on an I in an answer. You have to reduce it. Okay? So we did this last year, and I don't know if you remember, but if I gave you I to the 17th and wanted you to simplify it, well, I would assume you could gather that this pattern is going to repeat. I, negative 1, negative I, 1, correct? Do you want to keep repeating that pattern, or does anyone remember how we did it? Or anybody have a better idea? I mean, we could repeat it and go through it till we get to 17, couldn't we? Yeah, I don't want to do that, do you?
No.
Okay. Well, we know that we can break things up. Like when I had I to the fourth, I made it I squared, right? So we can do that. I to the fourth is ideally what we want because it is what? 1. So what if I took this 17 and divided it by 4? Okay. So how many times does 4 go into 17? 4.
And then there's 1 left over.
So then there's 1 left over. So I have I to the fourth, and I have 1 left over. Well, I to the fourth is 1 to the fourth times I. Well, 1 to the fourth is 1, so the answer is what? I. See what just happened? And Ainsley goes, oh, I remember doing this. So give me some number, Bladen.
42.
42. Okay, I to the 42nd. So we want to write it as a power of I to the fourth, and then whatever's left over. Okay? So how many times does 4 go into 42?
10.
10 with what left over?
2.
2. Okay, so I to the 4th is 1 to the 10th power is still going to be what? 1. And I squared is negative 1, which you should know. Should you not know? I mean, you should know that I squared is negative 1, correct? Okay, and so my answer would be what? Negative 1. Now do you see how it's working? Give me another number, Matt.
75.
Okay, so I'm going to divide it by what? 4. And then we're going to have our leftovers. So 74 goes into 75. Well, 4 goes into 7 one time with 3 left over. 4 goes into 35. 8. With how many left over? 3. Okay, so this whole thing is 1. Do I even need to write it down anymore? Nope. So I to the 75th is I cubed, which is negative I. Do one more. Do we need one more? Riley, give me a number. It can be ridiculous.
120.
120. Okay. Guys, does 4 go into 120 evenly?
Yes.
Yes. If 4 goes into it evenly, is there any left over? No. So it's just 1. Do you get how to do this?
Yes.
Okay. Okay, a complex number. I need to rewrite these. A complex number in standard form is A plus BI. This is standard form. When you write a complex number, it has to have a real part and an imaginary part. A is the real part and BI is the imaginary part. B is not imaginary on itself. What makes it imaginary? The I. So you need to write all your answers with the real part first and the imaginary part second. Got it? Mm-hmm. Just like when you learn to write a polynomial, you always go your variables in descending powers, right? Okay, so it says simplify. Well, negative 5 is simplified, yes? Mm-hmm. So what is the square root of negative 9?
Negative 3.
Okay, so what this is the square root of 9 times the square root of negative 1. Yes? Mm-hmm. What's the square root of 9?
3.
3. What's the square root of negative 1? I. Bless you. Okay, the square root of negative 75 plus 6. So, what's the negative give me? An I, right? Can this go in the front when I write my final answer? Has to go in the back, right?
Yeah.
So I got I. What's the square root of 75?
Does that have 1?
No, but it has a perfect square in it, doesn't it?
It has 8.
25 and
3.
3. So it would be what? What?
The square root of 3.
Did you say plus?
And I said 5 plus square root of 3.
Okay. So 5 square root of 3, I. Where is the I at?
Outside.
Outside in the back, right? It has to be in the back. So 6, is 6 done?
Plus 6.
Gotta remember your square roots, don't you? Okay, in reference, this is just saying that A plus BI, a real number, B would be 0, wouldn't it? It'd just be A. Imaginary number, B isn't 0. A pure imaginary number is just BI. It has no real part. So 17I is a pure imaginary number. 6 is a real number, yes? Okay. 6 plus 17I is an imaginary number. You can make any real number an imaginary number by just doing this. Seems kind of silly, but can I do it? Yes. Questions? I feel like I'm going really fast. Okay, all this box says, remember when it's a box like this, it's coming straight from the book. All this says is if you have one imaginary number and another imaginary number, and I say they're equal, don't the real parts have to equal? Don't the imaginary parts have to equal? Yes, that's all it says. So, this is interesting. This should be over here. Okay, so I need to solve for the variables. Set real parts equal. So give me a real part on the left.
13.
On the left.
On B?
On A.
Oh.
A.
A is the real part. What is the real part on the right?
13.
13. What is the real part on the left?
I already did that.
I mean, the imaginary part on the left. Thank you.
BI.
BI. What is the imaginary part on the right?
4I.
4I. So what is A?
13.
13. What is B?
4I.
Nope.
No, 4.
4. That's all you do. Okay, on the left, what is the real part on B?
A.
Mm-mm.
A plus 6.
A plus 6. What's the real part on the right?
6.
6. What's the imaginary part on the left?
2BI.
2BI. Now, technically, we don't need to take the I, but I'll show you what you can do with it. What's the imaginary part on the left?
5I.
Negative 5I. Okay, so to figure it out, you just divide by 2I, yes? So what are the i's always going to do? Reduce out. So you don't really need to write them. So B equals what? Negative 5 halves. And what does A equal?
1. No, 0.
0. This is one of those duh rules, I think. Because if they're equal, don't the real parts have to be equal? And the imaginary parts have to be equal? But what do we do when it's those duh rules? We tend to forget about them, don't we? Am I going too fast, guys? Riley, you good? Okay. Okay. Okay, all this says here is for addition, subtraction. Guess what you add? The reals. Guess what you add the reals to the reals, the imaginaries, and I touched it. Sorry. You add the reals to the reals, the imaginaries to the imaginaries. If I was going to write this, I would not write a sum and difference. I would have put a plus and a minus. I would write one thing. I would just write A plus BI plus and minus C plus DI. And then put this with a plus and a minus. It looks like I underlined it. That's a minus. We don't want to write things twice, do we? Okay, To add and subtract complex numbers, you add and subtract the real, you add and subtract the imaginary. That is it. Guys, it's just like terms, is it not?
Yeah.
Yes? Is it just like when you add and subtracted radicals? Yes. You can't combine things that aren't alike. Now, can I multiply anything I want? Yes, but I can't add or subtract them. Am I good? Okay. Additive inverse. Additive inverse is just, additive identity, is 0. Is that not the additive identity of anything out there? Yes? Okay. The additive inverse is just the negative of it. So you distribute the negative through. That's the one big thing that people forget. Okay, evaluate a plus bi plus negative a minus bi. What's your answer? 0. Because I would subtract a, yes, and subtract bi, and I would get 0. We're combining like terms, we're not solving. Could I solve this just like an algebra equation? Yes. Okay, so adding and subtracting complex numbers. So it would be 4 plus 1. 4 plus 1. And it would be 7 minus 6. I. So 4 plus 1 is 5. And 7 minus 6 would be positive 1, yes? So plus I. I typically don't even write this out. I just kind of like multiplication, right? But not the way I show my work. Not what we're doing. Okay, next is subtraction. What do I have to remember to do? Distribute. So it comes to be a negative 4 and a negative 2i. So I have 1 and negative 4 is negative 3. And I have 2i minus 2i is... Now it says write your answer. Well, this will say write your answer as a complex number or write it in the form of a plus bi. If I don't put this 0i, is it in this form? No. Now the book says write it in the form of a plus bi, but I'm going to tell you the back of the book would say negative 3. Okay, does it change if I throw more at you? No. Why don't you go ahead and do them? I believe in you. You guys done with the first one yet?
Yeah.
Got 5i?
Yes.
Okay.
One of it would be negative.
Yes. I got 0. You guys get 0? Every time I get 0, I check it twice.
Wait, why you're too long?
Huh? Well, because I have a negative I, a negative I, and a positive 2, so that would all 0 out, wouldn't it?
Oh, I forgot to choose my negative.
Yep, that's the biggest mistake people make is don't just, I mean, and that's any time we subtract. You got to distribute that negative, right?
Distribute to the 7.
To both.
No.
Next time I hand out candy, I'm only going to give it to Cadence and not you.
Okay. That's what I do.
Okay, am I good?
Deserve it this week.
Santa, you good?
Yeah.
Are you sure?
Yeah.
Okay. Okay, operations and complex numbers. You don't need to write this down, guys. All it is saying is the associative property applies. The associative property of addition and multiplication, commutative property of addition and multiplication, and the distributive property over multiplication, of multiplication over addition. That is all real number stuff, yes? It all applies. That's all it says. So, what do I need to do with these two things? I need to distribute them. So distribute them. Am I done with 8 minus 21 or 22i minus 21i squared?
No.
Nope. I have to change my I squared to -1 because I told you couldn't have any powers other than 1 in your answer, didn't I?
Mm-hmm.
Okay, so that makes it positive 21. So then I can combine it with 8. So I get 29 minus 22i. Yes?
Mm-hmm.
What's wrong, Jane?
How'd you get 29?
Because I've...
Oh, because you added those two.
Yes. Anybody else? You good back there, you two?
Yeah.
Okay, I don't think you're going to need conjugates today. I think this is where we're stopping for today.
Yay.